Welcome to Week 10, Question 1. Here we're going to be looking at finding and interpreting partial derivatives. So up until now we've been looking at functions where there's only one variable, usually x, and that doesn't really represent a situation or business application in most complete ways. Sometimes there are a couple of things or more that contribute to the various things that we're looking at in our business. So in this case, we're looking at a car dealership. It says it estimates that the total weekly sales of its most popular model are a function of the car's list price and the interest rate as a percent. So here we have two variables, list price and interest rate. So we have what we call a multivariable function, so it has more than one variable. You'll see later when we look at Lagrange multipliers that we can actually have three or more variables within a function. So here we have two. We have P, again, list price, and interest rate as a percent as I. And so the weekly interest rates are given by the following equation. In part A, we're asked to find the weekly sales if the average list price is $19,400 and if the offered interest rate is 8%. So we're going to look at the question and remind ourselves that it says that the interest rate is given as a percent, so we're not converting that to a decimal to use in this function, and we have the list price as $19,400. So for part A, we're simply finding the weekly sales by substituting 19,400 in for every P in the equation and 8 in for every I we see in the equation. So if we can just do that, we have F at 19,400 and 8 is our interest rate. So we have 99 times 19,400 minus 0.5, 19,400 and 8 minus 0.0025 and 19,400 squared. Okay, and when we solve for that, those values in this function, we end up with 902,100. Okay, so 902,100 will be the weekly sales when the average list price is 19,400 and the offered interest rate is 8%. So part B of this question asks us to find the two first derivatives of this function. Now there are two because we have two variables, and then it asks us to find the four second derivatives of this function. So it looks kind of like this. We can find the first derivative with respect to P of P, comma I, and from there we can find two second derivatives. We can take the second derivative again with respect to P, or we can take the second derivative with respect to I. Okay. So we can take the first derivative with respect to I, and then second derivative with respect to I again, or the second derivative with respect to P this time. Okay, so what does this all mean really? So when you have the first derivative with respect to P, that means that you are taking the derivative with respect to P and then you're keeping all other variables constant. So you're considering them as if they were constants. And we know that the derivative of a constant is 0. And then from there we can take the second derivative with respect to P again. So that means you're taking the derivative of the first derivative to find the second derivative. So here you've got FPP. So you're taking the second derivative using the FP first derivative and taking it again with respect to P. And in this case, you're taking the second derivative with respect to I, but it's F at PI, so you're taking the second derivative based on your first derivative, F at P. And the same happens over here. You're taking the first derivative with respect to I, which means all of the variables, so in this case P will be considered as if they were constant. And then you have two options. You can take the second derivative with respect to I, again, using the first derivative f sub I, or you can take the second derivative with respect to p. Okay, so what does that look like? Let's have a try. So here's the equation written again. We're starting again from the original function, of course. And the first derivative we're going to find is f sub p at pi. Okay? So let's have a look at each term. Just like we did with first derivatives with only one variable, we still have to consider what kind of function we have. Here we have three terms, 1, 2, 3. They are powers, so we have p, pi, and p squared as variables within the function. And again, we're taking the derivative with respect to p, so we need to consider I as a constant. So it's kind of, in this case, a coefficient along with negative 0.5 of p. Okay, so the first term we have is 99p. The derivative of 99p is just 99. We have negative 0.5 pi. So there our derivative will just be negative 0.5 I. Don't forget the I. And then here we have negative 0.0025 p squared. So remember, that's the power rule. So we've got 2 times negative 0.0025, which gives us negative 0.005, and then just p to the 1, or we can just write p. Okay, so the next first derivative we can find, of course, is for the second variable, f sub I of pi. So now we're looking at terms that have an I in it, and in this case, the first term, 99p, does not have an I in it. Negative 0.5 pi does have an I in it, so we need to attend to that, take the derivative, and the derivative there is just negative 0.5 p, and the third term does not have an I in it, so it's just a constant, and the derivative of a constant is 0. Remember, p is considered as a constant when we're taking the derivative with respect to I. So now we can start looking at the second derivatives, and the first second derivative we can look for is f at p I of p comma I. Okay, so that means now we're looking at the first derivative with respect to p, this one here, and we're taking the derivative with respect to I this second time. So we're keeping p constant, and we're looking for all terms that have an I in it. So the first term does not, the second term does, so we need to take the derivative of that term, which is just negative 0.5, and the third term does not contain an I. So p is constant, the derivative of that term then is just 0. Okay, so let's take the second derivative with respect to p again. Okay, so now we're looking at the first derivative with respect to p, so the same one we were just looking at. We're taking the derivative again with respect to p, so any term with an I in it will be considered a constant. So we have the first term, 99, that's a constant anyway. Negative 0.5 I, there's no p in there, so that's just a constant, derivative is 0. And then we have the third term, negative 0.005 p, and the derivative of that is just negative 0.005. Okay, so now we have a third second derivative we can take. This time we're going to be looking at the first derivative with respect to I, and we're taking that with respect to p. So let's see what we have to do. We're looking at this function here, this derivative, f sub I, and we're taking the derivative with that with respect to p. So there is one term in that derivative. It does have a p in it, and so the derivative there is negative 0.5. You're going to see that the second derivative pi and the second derivative ip have the same value. That's something you're going to see as a pattern going forward. The fourth second derivative we can take is that derivative with respect to I and with respect to I again. Okay, so now we're looking at the first derivative with respect to I and looking for any terms that have an I in it. In this case, we just have negative 0.5, so the entire second derivative is just 0. Okay, now what else is the question asking us? Let's go to the next page. So part C asks us to find and interpret f sub p and f sub I. So we're going to interpret the first derivatives where the price p is 19,400 and I interest is 8%. And they're asking us then to look at the values and interpret them in this business situation. Okay, so we're going to have to be reminded our f sub p is equal to 99 minus 0.5 I minus 0.005p. Okay, so we're going to substitute those values in. Remember, it's 8 as a percent, so you're just keeping it as a percent. The question should tell you. Okay, and we get a value here of negative 2. Okay, and let's look at f sub I with those same values. And f sub I was just negative 0.5p. So negative 0.5 times 19,400 is going to give you negative 9,700 or 9,700. Okay, so now the interpret part. So just like we did mathematically for f sub p, we looked at the derivative with respect to p and we kept I constant. So what this means when we're substituting values in is that we've kept the interest rate at 8%, but we have raised the price by $1, right? So marginal is the derivative. The marginal change in price of $1 will give us a weekly sales change of negative $2. So really quite insignificant when you change the price by $1. And when we're looking at the derivative with respect to I, that means that we're raising the interest rate by 1 percentage point while keeping the price constant. And we can see here we have quite a bit of a bigger difference in our weekly sales. Our weekly sales would be going down by $9,700. So you can see then that the impact of raising the interest rate on weekly sales is far greater than the interest or than the change if you're raising the price by $1.